So this video is trying to prove the famous Euler Mascheroni constant really exists. Okay, so the Euler Mascheroni constant is defined to be n goes to infinity, summation 1 over k from 1 to n minus log n. Then this log is use e as a basis. So e is the famous I guess you guys all know, right? Natural log. Okay, so the key if you use a computer, you can compute this like 0.577. So the key fact is that gamma really exists, really. Okay, and so key point is that in this video we want to show that gamma really exists. So that means this limit actually exists. Okay, so gamma is defined to be this un. So I define un to be 1 over k from 1 to n minus log n. Okay, so key point is that un exists. Key point is that un exists, right? Gamma exists. So what we need to show is that we use the Cauchy theorem. If we can prove a sequence is decreasing and is bounded below, then it must exist. So key fact, what we need to prove is un plus 1 less than un, means that un decreasing. And the second is that un is bounded below, so bounded below. Okay, so case by case. First one, un plus 1 is just this. Okay, from 1 to n plus 1 minus log n plus 1, and the un is just the same. Okay, so un plus 1 minus un is just 1 over n plus 1, because the first n terms are cancelled. Okay, so this one has this. Let me see. Is it correct? Yes. Okay. So the key point is that what we need to show is this less than 0. Okay. So I will use, suppose I let f of x equals to, okay, so you see okay, so suppose this is minus x minus log 1 minus x. Okay, and do a derivative, so I get minus 1 plus 1 over x. So you see this one is larger than 0 if x is larger than 0 but less than 1. Suppose x is a half, so this is 2. So this is larger than 0. And then also f of 0 is minus 0 minus log 1, so it's 0. So which tell you that f of x increase. Okay, f increase and in x equals to this region. Okay, so that means f of x is larger than 0 if x is in this region. Okay, so from here, what we have this identity. So what we show is that this is larger than 0 if x in 0, 1. Okay, so this tells you that if you plug x equals to 1 over n plus 1, then you have this log. So 1 over n plus 1 is just this. So this tells you that n plus 1 plus log n plus 1 is less than 0. So less than 0. Okay, so we prove un plus 1 minus un is less than 0. Okay, so the second is finally we want to show un is larger than 0. Okay, so the key point is that is to show this un is bounded below. So which one we need to show is this is larger than 0. Okay, and basically the easy way to do this is we just use some geometrical way. Unfortunately, if you try to use algebraic way, I guess it's somehow difficult to get an answer. So this is 1, this is 2, this is 3, and if you go very long, then finally you get okay. So I should probably this, you get n and n plus 1. Okay, so Okay, so this one is 1, right? This is 1, but the area of this red is 1, right? This is 2 over 2, and you keep going, and until you get this. So this is 1 over n. So you see from this picture, you know that this area, this red rectangle, not rectangle, this red this red rectangle is larger than the area below the integration to n plus 1. So which tell you that this area basically is larger than log, is larger than 1 over 1 to n plus 1 integration. Okay, so we tell you that this, so we tell you that this one minus log n plus 1 is larger than 0. Okay, and so you have this larger than log n plus 1 is also larger than log n. It's also larger than log n. So this tell you that 1 over k from 1 to n minus log n is larger than 0. Okay, u1 is larger than 0. So this tell you that u1 is bounded below. And from previous that the previous that we bounded below, and we also know that u1 is decreasing, so u1 exists. So gamma limit n to infinity, u1 exists. Okay, so it's very nice that we prove the Euler Mascheroni constant really exists. It really exists. Okay, so let me write down the final results. Exist, right? It's very good. It's very amusing proof. Very amusing. Okay. So thanks for you guys, and I will see you guys in the next interesting videos.